All right, students, we are doing the last two in section 4.8. 5. A stone is dropped off of a 200-foot cliff. Find A of t, V of t, and S of t. So this will be the first time that we have actually been asked to find the functions. Usually they're given. And 6 is a stone is thrown off a 200-foot cliff at 6 feet per second. So the first one, the stone is just dropped, and the second one, it's thrown, and I should say downward, because I'm not throwing it up in the air, I'm throwing it downward. That makes a difference. Off a cliff, a 200-foot cliff at 6 feet per second. Find A of t, V of t, and S of t. So there's a difference between just dropping it with no initial velocity and then throwing it downward at an initial velocity of 6 feet per second. So let's take a look at what I've done here. You need to know, to do this problem, acceleration due to gravity, and it depends on if you're working in feet or if you're working in meters. The one on WebAssign, I do know that you're going to be working in meters, so that I thought I would work with feet. And acceleration due to gravity is negative 32 feet per second squared, and the negative means downward. And in WebAssign, you'll be doing negative 9.8 meters per second squared. All right, so that's a little bit different. I mean, they're measuring the same thing, just different units. So what we do is we start off with our acceleration function, and our acceleration is constant. So on this one, my acceleration is just negative 32. It's constant. No matter what time you put in there, the answer is negative 32 feet per second, or feet per second squared. All right, now we have that as a function. It's a constant function. We're going to find velocity. Velocity is the antiderivative of acceleration. So I am going to find the function whose derivative is negative 32. And I do that by just plugging a t right beside here. Negative 32t, because the derivative of that is that, and plus c. Now we need to find this plus c, and that has to do with your initial conditions. Now initially, v of 0 is equal to 0. That is because the initial velocity is 0 because the stone is dropped. There's no throwing with any kind of velocity. So our v of 0 is 0 because the stone is dropped. And the ones we were doing with Wile E. Coyote in the very beginning of class, he was also just falling. He never was pushed down or had any initial velocity. So here we go. I'm going to put v of 0 equals 0. So I put v of 0 equals negative 32 times 0 plus c equals 0. And that solves for c to be 0. So now I go back up and put in my 0 up here, and that gives me my velocity function. V of t equals negative 32t. Some very simple functions. Now, I'm supposed to find, what are the directions? Find A of t, V of t, and S of t. So 2 down, 1 to go. My S of t is position. So I'm going to go backwards, which is the antiderivative. And remember your power rule. We're going to add 1 to the power and divide by it. That's your power rule. So I've got a power of 1 here, and when I add 1 to it, I get negative 32t squared over 2, and then you always have this plus c. And I'm taking negative 32 divided by 2, and I'm getting negative 16t squared plus c. Now to find c, initial conditions. Our initial condition, s of 0, is 200 feet, because it's 200-foot cliff. So the initial height or position is 200 feet in the air. So I'm going to substitute in s of 0 equals negative 16 times 0 squared plus c equals 200, and that will give me c equals 200. And now I've got my position function. S of t equals negative 16t squared plus 200. I just put that right back in there. So I have my position or height, I have my velocity, and I have acceleration. All right, we're going to come back and see what happens if you give it an initial velocity.